Okay.
Let's start our discussion now. Juvency.
Yes, but give me 1 minute. I'm
Your,
connecting my
your voice is very low.
computer.
Your voice is very low. Can you please repeat again?
Let me connect my computer.
Sure. No problem. Take your time.
I'm using phone.
Take your time. No problem. I'm creating topology. Take the time.
Okay.
We are trying to implement today. We are trying to implement today root summarization concept.
Yes.
Root summarization concept, and we will focus on RIP, EIGRP, and OSPF root summarization concept. In previous session, we complete our summary address concept, how to find a summary address. If you have multiple roots, how to find summary address of the root, how to use, how to run summary address in protocol. We are trying to discuss in our practical implementation. So this topology, this design is for RIP and EIGRP root summarization. Please wait. I'm creating this design. Wait.
Okay. Now my voice is okay.
Now I'm configuring IP address here. IP address. IP address in between R1 and R2. I'm using 10.1.12.0 network slash 24.
Hi
Now
dear. My
in
voice
between.
now is okay.
Yes, can you hear me now?
Okay. Yes. Now it's okay.
Now 10.1.24.0 slash 24 in between R2 and R4 and in between R2 and R5. 10.1.25.0 slash 24. Okay, let's configure IP address. And for roots, what I'm doing for roots, I'm creating multiple loopback interfaces here. So
Okay.
3.3.0.1 slash 24, 3.3.1.1. So here loopback can help you for this implementation. We can create multiple loopback interfaces 3.3.3.1, 3.3.4.1, 5.1, 6.1, 7.1. Let's copy this. We can paste in Notepad because Notepad can help you to create multiple loopback interfaces. Wait, 3.3, I'm trying to replace with 4.4. So I'm creating four loopback on R4.
Okay.
Now, sorry, eight loopbacks on R4 and eight loopbacks on R5. So 4.4, I'm trying to replace with 5.5.
Mm.
Copy. And now
Okay.
we can paste here. Now let's configure IP address as per our design. IP address as per design. And we can go with RIP and
Thank you.
EIGRP root summarization concept into this design. Root separation. Let's try to configure IP address first. Then I will advertise all the routers in EIGRP protocol, for example. Let's start our IP address configuration first. So R1 interface fast Ethernet 0/0 as per design 10.1.12.1 mask
One.
no shutdown. Okay, I'm trying to advertise this network into AIGRP protocol. So router AIGRP 10.1.12.0 wildcard mask, and I'm not using this time. I'm not using no auto summary command because I want to show you auto summarization first.
Okay.
Now R2 0/0 because RIP and AIGRP they do auto summarization by default.
Yeah.
10.1.12.2 mask no shutdown 0/1 10.1.23.1 mask no shutdown. Now fast Ethernet 2/0 10.1.25.1
25. Yeah.
mask no shutdown. Now let's try to advertise wait 23.1 1/0 24 1/0 10.1.24.1 mask no shutdown. Show IP interface brief. Let's advertise all the networks into EIGRP protocol 10.1.12.0 wildcard mask 10.1.23.0 wildcard mask network 10.1.24.0 wildcard mask 10.1.35.0 wildcard mask, and I'm not using a no auto supply command right now. Let's go to R3, and on R3 yes I'm creating one physical I'm configuring one physical interface 10.1.23.1 mask no shutdown, and we can create 8 loopback interface. Okay,
Look back. Yeah.
wait, duplicate IP address. Wait, I'm using 23.2 here. Shut down and then
No, not sure.
no shutdown. Show IP interface brief. Yes. Now let's try to create 8 loopback interfaces. Okay, these are acting as a 8 networks on R3 router. So for loopback configuration, you can go with interface loopback 0, IP address 3.3.0.1 mask exit interface loopback 1
Okay.
3.3.1.1 mask /24. So you can create loopback like this. Otherwise, you can take a help with Notepad. In Notepad, we can create loopback interface here. Notepad can help you to create multiple loopback interfaces. So interface loopback 0, 3.3.0.1 mask. Now copy. Now interface loopback 1, loopback 2, loopback 3, loopback 4, loopback 5, loopback 6, loopback 7. 2.1, 3.1, 4.1, 5.1, 6.1, and 7.1. You can copy and you can paste here on R3. 8.
Okay. Very
Yes.
speed.
Yes, loopback can end. Yes. Now let's advertise loop interfaces in protocol 10.1.23.0 wildcard mask. And now what I'm doing, I'm trying to advertise all loopback interfaces in a single line. Otherwise, what you can do, otherwise you can advertise this first network, then next network, then next network, like this. For example, a network 3.3.3.0.0 wildcard mask. Then you can advertise 3.3.1.0 wildcard mask. I'm not using this option. What I'm doing, I'm I'm taking help with wildcard mask. Okay, I'm trying to advertise. My point is, I'm trying to advertise all the loopback interface, all the networks, 8 networks in a single line. Okay, and loopback can help network 3.3.0.0. So I'm trying to match only 2 octet. Wildcard 0.0.255.255. Clear my point?
Okay.
I'm trying to match only 2 octet. You will see. Clear now?
Yes, yeah.
Now let's go to R4. I'm not using no auto summary command here. Let's go to R4. Fast Ethernet 0/1. 10.1.24.2 mask, no shutdown. Let's create loopback. So I'm changing 3.3 into 4.4. You can copy, you can copy and paste here. Show IP interface brief. Now router EIGRP 10.1.24.0 network 4.4.0.0 wildcard mask. Let's go to R5. R5 interface fast Ethernet 0/1 25.2 mask 255.255.0 no shutdown. And yes, we can create loopback interfaces here. So 4.4 with 5.5. Now let's try to advertise these interfaces in protocol. So router
Yes.
EIGRP 10.1.25.0 wildcard mask 5.5.0.0 wildcard mask, and I'm not using no auto summary. I'm not using no auto summary. Juvency, can you hear me, dear?
Yes, I can
Any,
hear.
any problem in IP address configuration and route advertisement?
No, no, no,
Okay.
no, no problem. But I didn't show. I didn't see on the router 3, 4, and 5 when where you do the no shutdown interface.
No should see here we have 3 routers. See, okay, in loopback interface.
Yeah.
See, in loopback interface, no shutdown command is not required.
Okay.
In loopback interface, in physical interface, yes, no shutdown
In
command is
physical.
required, but in loopback interface, it's not required.
Okay. But I didn't see even in the network interface for L4 and L3. I don't
Uh,
know if
this is
you
this
can
is
check.
this is loopback. See, L0, L1, L2, L3, L4.
Yes, this I understand. Mm.
Yes. Clear this loopback configuration?
No, loopback configuration, I have no problem. But I say if you shut down the interface, fast Ethernet 01 for L4, for example, you can check.
On R4.
Yes,
Okay. Show.
router 4.
Yes, show IP interface brief. Yes, I have IP address on 0/1.
Is up, right? Okay.
Yes.
Okay.
Here is the configuration. Wait.
Yes, you did it. No shutdown. Yeah, I see. Okay. Maybe it
Now,
was very fast.
yeah. Clear now?
Very clear.
Okay. Now into this design, we are not using any summarization technique. And if you
Okay.
remember our discussion, RIP and AIGRP, they do auto summarization by default. Okay, it
Yes.
means here we have auto summarization technique. Here we have. It means
Mm.
R3 router will summarize these networks in a single line and then send to the R2. Then R2 will send this route information to R1. Same R4
Okay.
will summarize this route in a single line and then send to the R2. Same R5. summarize the route and send to the R2. Then R2 will send these route information to R1. So let's go to R1 router and we can verify route information. So RIP and
Yes.
EIGRP, they do auto summarization by default, but the problem with the auto summarization is it's a class full summarization. You can see now, you can see, yes, we have a single line entry. We have a single
Okay.
line entry. Okay. We have route with which is start with 3. We have all
Okay.
the routes which is start with the 3, but it is not true. It's not true. Okay. Because here we have only 8 networks, right? We have
Yes.
only 8 networks, but as per my routing table, you can say you have a route which is start with 3, but it's not true. We have only 8 networks. Same R4, single line entry, class full /8/8/8. This is the issue with class full summarization, auto
Okay.
summarization. That's why I'm not using auto summarization. What you can do, you can go to R3. You can use a command no auto summary. No auto
Okay.
summary. Now, if you go to R4, go to protocol, router, yeah, GRP, then no auto summary. Let's go to R5, no auto summary. Done.
Mm.
So we are not using auto summarization technique on R3 and on R4 and R5. If you go and check on R1 router again, so right now there is no any route summarization technique, no summarization. So if you check your routing table again this time you can see you have route information. You have all the route information in a
Uh,
separate line,
okay.
right?
Okay.
Clear now?
Yeah.
You have all the route information in a separate line. You have a big
Hmm.
routing table. You are not using any route summarization technique.
Summarization. Okay.
So now I want to go with manual summarization.
Manual. Manual
Summarization.
summarization.
Clear now, Juvency?
Yes. Very clear.
Okay, so for manual summarization, R3 administrator, R3 administrator will find summary address of these routes.
Okay.
Summary address of this. So summary address of these routes. If you remember, we already complete one question with 7.7.0.1, 7.7.1.1. Remember our one question, how to find
Yeah.
summary address 7.7.2.1, 3.1, 4.1. If you remember this
Yeah.
question, okay, this question summary address is 7.7.0.0/21, right?
21. Yes.
Here we have what? Here we have 3.3, 3.3.
Mm.
Here we have 7.7. Here we have 3.3. Here we have
Yeah.
4.4. Here we have 5.5. So now, yes, I have a summary address for these networks. What? 3.3.0.0/21. Any problem?
Yes. No.
Now for 4,
But this was the
dot,
problem is for calculation. This one
yes,
I will
calculation. You
do by
need
myself.
practice. You need practice. Yes, you need practice.
Yes.
Five
Very
dot
practice.
5.0.0
Zero.
slash 24. So yes, you have summary address of these routes. Now, how
Oh,
to use these summary address in routing protocol? So let's go
okay.
to R3. Now,
R3.
R3 administrator want to send summarize route, want to set summary route.
Yes,
So
to
yes,
R2.
R3 administrator has what he has summary address of these networks. So now, how to summarize? So in RIP and in EIGRP protocol, you can summarize your routes on interfaces. So you can go
Okay.
to interface fast Ethernet 0/1.
One.
And what
Okay.
is command syntax? IP summary address.
Address.
IP
Oh,
summary address.
okay.
Now into this design, we are using EIGRP protocol, right?
Yes.
But in case if you are using RIP protocol here, you have a same command syntax. Let me show you. If you type question mark, you can see you can decide. You can decide
Okay.
protocol or EIGRP. You can decide. We are using EIGRP, so I'm using EIGRP. If you are using RIP, you can use RIP command. So I'm using EIGRP, and if I'm using EIGRP, then I need to define autonomous system number 10. And now you can type your summary address. What is summary address? 3.3.0.0.
00,
And what is slash 21? 255
255, 255,
48.0. Done.
to, yeah.
Done configuration.
Okay.
Now you can go to R4. You can go to R4. Now interface fast Ethernet 0/1 IP summary address EIGRP autonomous system number 4.4.0.0 255 255
4, 8,
248.0.
4, 8. Okay.
Now R5 interface fast Ethernet 0/1 10.1. No, command is for IP summary address. R4 we complete. Yes. R5 IP summary address EIGRP 10. And what is summary address? 5.5.0.0 255 255 248.0. Done. Now you can verify this time on R1. On R1, now you can check your routing table this time. This time, okay?
How to
Wait.
A1? A1, okay.
R1. So I'm trying to verify on R1. You can see now I am receiving
Yeah,
summary address
yeah, yeah, yeah.
3.3.0.0/21.
21. Nice.
And now, what router can understand with this 3.3.0.0/21? What router can understand? Let me show you. Let me tell you. Let me tell you it. What router can understand with this option? What 3.3.0.0/21? So /21 means what? 255, 255, 248.0, right?
Yes.
248. If you change this into binary, so 11111000. What is increment bit? Increment bit number is 1248. So you can add this increment bit. If you remember subnetting, you can see, okay, this calculation
Mm.
can help you. So increment bit is 8. So my network is 3.3.0.0. And this increment bit I can add in third octet. Third octet, wait. Third octet. So now 3.3.8.0. Before 8.0, 3.3.7.255. And this is your range. This is your range. And now you can see into this
Oh,
range what you have. 3.3.0 network, 1 network, 2 network, and 7 network. 3.3.0 network, 1 network, and last 7 network.
7.
So with this
Oh,
/21, the router can understand, yes, there are only 8 root
7.
information into the summary address. Clear now my
Okay.
point?
Okay.
Yes. This is what? This is what root summarization technique in RIP and EIGRP. I hope this point is clear for you.
It is clear, my
Okay.
friend.
Now we are trying to implement root summarization now in OSPF protocol. Okay. So give
Okay.
me 5 minutes because I'm trying to create a separate design. I'm trying to create a separate design for OSPF. Give me 5 minutes.
Okay.
So into this design, we have three area
Okay.
10, area 10, area 0, area 20, 10 dot 1 dot 12 dot 0 slash 24, 10 dot 1 dot 13 dot 0 slash 24, 10 dot 1 dot 14 dot 0, in between R1 and R4, 10 dot 1 dot 45 dot 0, in between R4 and R5. And now I'm creating some loopback interface here. Wait. So 5 dot
You can
5
use the
loopback.
same.
Yes, yes. Can you hear me, GNC?
Yes, I can hear you.
Okay, so I'm
I
creating.
was saying if we can use the same look back here, same look back address.
So I'm creating 8 loopback interface on R5, and these loopbacks I will advertise in EIGRP protocol. Now let's go to Notepad. 5.5 I'm changing in 2.2. So we can create 8 loopbacks on R2. Eight loopbacks on R3. Let's configure IP address as per design, okay? So I'm trying to
But
configure IP address
R4 no need, right?
yes, R4. On R4, we have only physical interfaces.
Okay.
So now what I'm doing, I'm trying to, wait. We can configure IP address as per design. We can advertise our routes as per design. Into this design, you can see we have ABR router and ASPR router. Remember OSPF concept, basic concept. In OSPF, we have two type of routers, right? ABR router, area border router, and what we have? ASPR router, autonomous system border router. You can see
Yes, I
what is
can hear
ABR
you.
router? Remember from basic OSPF concept, basic OSPF concept from CCNA training. What is ABR router? Area border router. Okay, for example, into this design, this router is acting as a API router. Why? Because his one interface, this R1 interface is a part of area 0, right?
Okay.
And other interfaces, they are the part of different area. So
Yes.
this router is called what? Area border router. A router
Oh,
one interface is a part of area 0 and other interfaces, they are the part of any other area. Router is called ABR, area border router. R4 is also a area border router because his one interface is a part of area 0, other interface is a part of area 20.
yes.
Now, if you talk about R5, R5 is a ASPR router. R5 is
Yes. Yes.
what? ASPR router, right? Why?
Yes.
Because here, see, what is ASPR router? Autonomous System Border Router. Why this router is a ASPR router? Because his one interface, this router one interface is a part of OSP of any area, any
Okay.
area. So this R5 one interface is a part of area 20 and other interfaces, they are the part of any other routing protocol.
Okay.
So this router is called ASBR router in OSPF network. Clear my point?
Clear.
Okay, now. So let's go here. Wait. Let's configure IP address first. IP address configuration, then we can advertise our network in area. Let's start our configuration with R1. On R1, we have three interfaces. 10 dot, 10 dot, 1 dot, 12 dot, 1 mask, no shutdown, 0/1, 10 dot, 1 dot, 13 dot, 1 mask, no shutdown, fast Ethernet 1/0, 10 dot, 1 dot, 14 dot, 1 mask.
Mm.
Wait, let me use no shutdown, 1/0, no shutdown. Show IP interface brief. Now let's advertise our networks area as per our design.
Mm.
Router OSPF process ID. As per our design, 10 dot, 10 dot, 1 dot, 12 dot, 0. Wildcard mask, area 10. Network 10 dot, 1 dot, 13 dot, 0.
But,
Wildcard mask, area
but
10.
it was the area 10.
Yes, area 10. See,
But on the router,
we are the
you
part of
configure.
area 10.
Yes, but for OSPF, you said OSPF 5.
So this is process ID, remember?
Process ID, yeah.
In OSPF, in EIGRP, this is called autonomous system number. In OSPF, this is called process ID number. Okay,
Okay.
process ID number. So now network 10 dot, 1 dot, 14 dot, 0, wildcard mask, and area 0 as per our design. Any problem in IP address configuration and route advertisement?
No,
We'll see.
it's
Okay,
clear. It's
let's
clear.
go to R2.
No.
On R2, yes, we have one physical interface and 8 loopback network interfaces. 10 dot, 1 dot, 12 dot, 2 mask, no shutdown. Now let's create 8 loopback interfaces. Okay, so we can take a help with Notepad. So 5.5, I'm trying to replace with 2 dot. You can copy. You can copy and you can paste here. Now show IP interface brief. Now let's go to OSPF protocol, and as per design, I'm trying to advertise all the interfaces, all the networks in area 0. Loopback, yes, 2.2 wildcard mask, 0.0 wildcard mask, and I'm trying to advertise in area 10. Let's go to R3, R3, interface fast Ethernet, 0/1, 10 dot, 1 dot, 13 dot, 2 mask, no shutdown. Now
Loopback.
interface, loopback interfaces. Wait, let's go to loopback interface 2.2. I'm trying to change in 3.3. We can paste loopback interface here. So IP interface brief. Now
Oh,
router OSPF process ID 10 dot, 1 dot, 13 dot, 0, wildcard mask area 10, and loopback 3.3, 0.0, wildcard mask area 10. Clear now, Juvency?
here.
Let's go to R4 router. On R4, we have two physical interfaces. 0/1 is connected with R1 10 dot, 1 dot, 10 dot, 1 dot, 14 dot, 2. mask, no shutdown, 0/0, 10.1.45.1, mask, no shutdown, show IP interface brief. Okay, let's advertise
Mm,
our network in area. So 10.1.45.0 wildcard mask. As per our design, I'm trying to
yes,
advertise 45 network in area 20 and
20.
network 10.1.14.0 wildcard mask area
Area
0.
0.
Let's
Mm,
go to last router R5 fast Ethernet 0 slash 0
0,
10.1.45.1
2.
mask. And now we can create loop back. Okay, wait. 3.3, 3.3. I'm trying to replace with 5.5. Now show IP interface brief. Router OSPF process ID 10.1.45.0 wildcard mask area 20 exit. And now router EIGRP 10 network 5.5.0.0 wildcard mask. And I'm using no auto summary.
Yeah, I have one question.
Yes, sure.
For the wildcard mask of loopback, the slash, we have slash 24.
Yes,
But on the wildcard mask, you are using 200, 255, and 255.
yes. Because see,
Why?
if you remember
Mm,
wildcard mask concept, a wildcard can help you in EIGRP protocol, in OSPF protocol, you can use a concept of wildcard mask. In RIP protocol, there is no concept of wildcard, but in EIGRP, in OSPF, you can go with wildcard mask. It means you can advertise your network. With
okay.
wildcard mask, you can define what bit you are trying to advertise.
Okay.
What bit? For example, here what we have 5.5.0.0, right?
Yes.
And I'm using what? 50.0.255.255. In wildcard mask. Okay, how to find wildcard mask? Any idea? UNC? If you
Mm,
remember CCNA training, how to find wildcard mask? Let me tell you. If you remember GSM minus DSM, this is the formula to find a wildcard mask. What is GSM? Global subnet mask. What is global subnet mask? 255.255.255.255 minus DSM, default subnet mask. For example, I want to advertise this 10.1.45 network on R4, for example. So what is default subnet mask right now? /24, right? Do you see?
24. Yes.
So I can minus 255.255.255.0.
0.
So
Yes.
now if you minus 0.0.0.255, this is
Mm,
wildcard mask. So you can
wildcard.
calculate, you can type here, no problem. But what is the benefit of wildcard mask? I can find the wildcard mask, but what is the benefit of wildcard mask? With wildcard mask, you can match your bit in route advertisement. You can tell what bit I want to advertise in protocol. For example, with this wildcard mask, my point is with this wildcard mask, you are trying to advertise first 3 octet. First 3 octet. See, wait,
Mm,
let's go to R4. See, R4. So what we have 10.1.45 network. And what wildcard mask I'm using? 0 dot 0 dot 0 dot
Mhm.
255, right?
Yes.
What is 0 means in wildcard? 0 means must match.
Okay.
Must match. It means I'm saying with first 0, I'm saying please match. Here is a 10. Second, please match. Here is a 1. Please match. Here is a 45. And what is 255 means? In wildcard, I don't care. I don't
Okay.
care. It means here, here there is anything in between 1 to 255, anything.
Okay.
Now there is a one more benefit of wildcard mask. One more benefit. In case if you want to advertise this specific IP, this specific IP in protocol, yes, wildcard can help you. Wildcard can help you. If you want to advertise this specific IP, not complete network, specific
Okay.
IP. So you can use, for example, I want to advertise, so I can use 10.1.45.1. And what is a wildcard mask I will use? I will use wildcard mask 0 dot 0 dot 0 dot 0. 0 means what? Must match.
Must
It
match.
means it means I'm trying to match all the bits. This
Okay.
will this will give you great security. What security? What security? For example, after 1 week, after 10 days, if any administrator change
Mm.
IP address on this interface, for example, 45.50, for example. If anyone change IP address, neighbor relationship will down. No one
Okay.
can change IP address. Clear now? Wildcard mask will provide you a great security.
Okay.
So now here what we have, what I'm doing with this, wait, with this wildcard mask, I'm trying to wait. Let's go to R5. With this wildcard mask, I'm trying to match only first two octet. And 255 means what? I don't care here. So what I'm doing, I'm trying to advertise all networks. I'm trying to advertise all these eight networks in a single line. That's why I'm trying to
Okay.
match only 5.5. The rest, I
Okay.
don't care. That's why I'm using wildcard 0 dot 0 dot 255.
Clear now.
Now let's
Thank you.
go to R5. And here, what I will do, on R5, I'm using redistribution command. Remember redistribution topic?
Yes. Yeah. Yeah. Yeah.
With redistribution, you can exchange different routing protocol information with each other. So what I'm doing,
It,
and what I'm doing, I'm here on R5. I'm trying to redistribute EIGRP protocol into OSPF,
OSPF.
So you can go to OSPF protocol, router OSPF, and what is command? Redistribute and protocol
Distribute.
EIGRP, autonomous system number, and command is what? Submit. Done.
Um,
Remember this command
okay.
in redistribution
Yes.
topic?
Yes.
Now
I
let's
remember.
verify our routes. So we advertise our networks in area, in OSPF, in EIGRP as per our task. Now, in case if I'm trying to verify routes information, so let's verify route information on R4 here on R4. Why?
Mm.
Because R3 routes I can verify, R2 routes, R3 routes I can verify here, R5 routes I can verify here. So let's go to R4 router. And here I'm trying to verify routing table information. Show IP route OSPF. Okay, before press enter here, let's verify some points. If you remember RIP and EIGRP, they do auto summarization by default, right, Juvency?
Yes.
But in OSPF protocol, OSPF can't support auto summarization.
Oh, yes.
In
I just
OSPF,
read it.
in OSPF, you can only go with manual summarization. There is no
Manuals.
auto
Yeah.
summarization concept here.
Yeah.
You can
And
verify.
SIS also.
You can verify. You can verify. Show IP route. You can see you are receiving you are receiving all the routes in a
Mm,
specific line, right? See,
yes.
you are receiving 2.2.2 routes on a specific line. You are
Mm,
receiving 3.3.3
it
network
does.
in a specific line. This is OIA routes, OSP of inter-area communication routes.
Okay.
Now OE2, this is OSP of external routes, 5.5 network.
Mm.
So in
Yeah, it's
OSPF, there
coming
is
to another protocol, right?
so in OSPF there is no concept of auto summarization. Juvency, clear my point?
Yeah. Yes, very clear.
Now let's talk about summarization here. So if you remember RIP and EIGRP, in RIP and EIGRP protocol, you can summarize your routes on any router. You can summarize your route on any routers. If you remember our design, if you remember our previous design, R3,
Yes.
R2, R1, R4. Remember this design in AIGRP and RIP?
Yes.
So here what you can do, R3 administrator can summarize his route and then send to the R2.
Okay.
No problem if you want to summarize routes here on R2. If you want to summarize routes on R2 router, no problem. You can summarize here, no problem. In RIP and AIGRP, you can summarize your routes on any router. But
Oh,
in OSPF, we have two type of summarization. In OSPF, we have two type of summarization. The first one is area base summarization, and the second option is what? ASPR base summarization. So we have two type of summarization: area based summarization and ASPR based summarization. Now let's talk about One more points. Within an area in OSPF, you cannot summarize your routes within an area. You cannot. For example, if you want to send summary routes, R2 summary routes to R3, R3 summary routes to R1, not possible.
not
Within an
possible. Yeah.
area, you cannot summarize your route. Clear my point?
Yes.
If you want to send summary routes, so you can send to any other area. Now into this area, for example, this area 10, into this area, I want to send summary routes of R2, summary route of R3 I want to send to any other area. So what you can do, you can go with area-based summarization. And in area-based summarization, you can find area border router into this area 10, because you can only summarize on border router into this area. If you have 50 routers, into this area you have 50 routers. If you want to send all routes, if you want to send all summary routes into any other area, you can do this, but you need to summarize your routes on border router only. So into this
Yes.
design, R1 is a border router, right, Juvency?
Yes. Right.
So let's go to R1 router. And yes, I have a summary address. I have a summary address 2.2.0.0/21. Okay, summary address 3.3.0.0/21. So let's go to R1. Let's go to R1. I told you, you can only summarize on border router. What is command syntax? You can go to protocol, router host your process ID. And what is command syntax? Command is area. Command is what? Area. And now, which area routes you want to summarize? Because maybe you have multiple areas are connected with R1, maybe area 10, area 30, area 40, area 0. Multiple areas are connected with this border router. So here I'm using area 10. I want to summarize only area 10 routes. Juvency, clear my point?
Come
Juvency,
again, please.
clear now?
Sorry, come again, please.
My, my,
You
my
say
point, my
from
point
area.
is, my point is, my point is, if R1 has multiple area, because here you have area 10, right?
Yes,
Area 0.
and
Maybe one more area you have here. For
yeah.
example, area 40. One more area you have, area 30. So which area you want to summarize? Which area root you want to summarize? You need to define here area number.
Okay.
Okay. So
Yes.
now I want to summarize area 10 roots. So area 10. And now if you type question mark, you can go with this command range. Range
Range.
command. See,
Okay.
summarize
Okay.
root border
Mm.
routers only. This command you can use
Okay.
on border routers only. So now range command. And what is summary address? 2.2.0.0, 255, 255, 248.0.
Okay.
Now area 10 range 3.3.0.0, 255, 255, 248.0. Yes, yes, Juvency. Clear now?
Very clear. I
Okay.
understand.
Now let's go to R4 again. And this time I'm trying to verify my routing table information. Let's verify our routing table again. This time R4 is receiving summary route information.
Okay.
Clear now?
Yes.
But I'm looking
Remaining
for but I'm looking for external route summarization. For
R5.
this, you can go with this concept. What? ASBR based summarization. And for ASBR based summarization, you can go to ASBR router. And into this design, R5 is a ASBR router, right?
Yes, yeah, yes.
Yes, let's go to protocol router OSPF process ID. Router OSPF process ID. And now command syntax is what? Summary address. Summary address. And now you can type summary address 5.5.0.0, 255, 255, 248.0. Done.
Okay.
Let's go to our R4 again. And I'm trying to verify my routing table this time. You can see
Okay.
I have summary root of OSPF and summary root of external root.
So,
And this is our topic, root summarization. I hope it's clear, Juvency.
yeah, it's very clear. But
Now,
we'll do some exercise.
okay, now we will continue our session on Monday now. And on
Yeah.
Monday, we'll start our protocol. Let's start our discussion with OSPF protocol. And I will discuss OSPF protocol from Ccnp concept. Okay, Juvency?
Nice.
Okay.
Yes,
OSPF will
thank you.
take time. OSPF will take minimum 5 to 8 hours. Only OSPF.
Okay.
Okay. So let's continue our session on Monday. I'm sharing this recording after 1 hour because I have next batch. Okay. You can see.
Okay.
Bye,
Thank
dear.
you.
Take care.
Thank you.
Bye.
Thank
Bye.
you.
Bye.
Bye.